job. All right, here's your early leaders. Maya. All right, here we go. Here's question 2. All right, good job. All right, whatever that means. Here we go. Here's question 3. All right, nice job. All right. Last place is not. You have another Kahoot. This one's going up. You do have another one. Might as well do it. So if these guys are done, because the next like 15 minutes, like we have 30 open answers today. Yep. They've been doing all three of them like an hour 5-ish. Yeah, so if we get done with this in the next 15 minutes or so, yeah, we should do good.
Ah, not so good.
Look at that.
Yeah. Hey, let's check this one out real quick. All right. Hey guys, listen up, please. Well over half of you missed this one. Derivative of function is given by f prime equals that right there. How many points of inflection does the graph of f have on the open interval -2 to 2? So did you guys turn to your graphing calculator and graph f prime?
Yep.
Okay. So if we were to do that on the interval, I guess, let's go with this, -2 to 2, if that's your window, if you're looking for points of inflection of f and you graph f prime, what are you looking for on the graph of f prime to tell you that you're going to have an inflection point on f? Maxes and mins, yeah. So let's see here. Do you have the graph up right here? Can you go to -2 to 2 on your window?
I think the problem is when you did that, you actually, depending on what your y-axis is, you didn't see.
Oh, gotcha. Okay, gotcha. So it looks like this, roughly. So what Jake is saying is maybe some people didn't see this one and this one if your window is not totally appropriately sized. Does that make sense? Yeah? Any questions? So I guess investigate further, right? If the window is kind of cutting it off a little bit, don't assume anything. Okay, cool. Good deal. All right, here is the leaderboard. It's really close. Here we go. Here's question 5. Yep, good job. Yep.
The other one's no. So
That might be a good one to finish on, actually. Hey, I don't know if you're the one that's just like guessing. If there's like one person every time, maybe it's just a phone, you wake up, I'd appreciate it if you would try. If you're here just to screw around, I would prefer you just not be here. It's right, actually right there. It might be challenging to get done in 2 minutes. You got about 20 seconds left. You all might be wrapping it up at the very last second possible. It's Hey, was that a time issue? Yeah, that's a tough one to get done in 2 minutes. So if you like fully got that one done and corrected in 2 minutes, that's pretty impressive. Okay, cool. All right, leaderboard is right there. All right. Here's question 7.
Today is the opening day, isn't it? Or a week
It's a
from
week from
tomorrow.
tomorrow.
Tomorrow's Friday. I'm thinking today's Friday. Yeah. No, that'll be good.
Yeah, so I'm pretty
Is
excited.
it an afternoon?
Yeah, it's like 2 o'clock or something like that. And so, yeah, they're doing lunch at like 11:30. I've got 2 classes in the morning, like 2 classes in the afternoon, for like a review and a quiz. So I hope the spiel isn't too painful. Nice work. All right. Any questions on that one? Yes? Okay, let's check it out. All right, question 7. All right, so question 7, I would say, is a fundamental theorem of calculus sort of question. When you guys see something like the integral of a derivative, what's the interaction between an integral and a derivative going to be? Cancel each other out, right? But we're doing, of course, a definite integral. And so I think I would just piggyback right off this and say that this equals f of negative 1 minus f of negative 4. So I'm doing the full fundamental theorem there by essentially showing how the antiderivative cancels out the derivative, and then I'm subtracting the difference, the evaluation there, top minus bottom. So then I think what I can do is I can take these values right out of the table. So f of negative 1 is negative 1.5. F of negative 4 is 0.75. So this would be negative 1.5 minus 0.75, which leads us to this negative 2.25. So this whole row, of course, totally unnecessary. Of course, these two columns as well, totally unnecessary. They got to give you a little bit more, so you have to pick. But any follow-ups on that one? Do you think that's the easiest way to do that one? Okay. Right. Okay. Right. So here is our leader board. Looking pretty similar. All right. Here we go. Question 8. That's a cubed root there. In case you're having a hard time seeing that. Cubed root of 1 plus t squared. All right, that's pretty good. All right, whoa, it's super close. Right now, Maya and Caroline. Very close. All right, here we go, number 9. Notice here they're giving you a formula for surface area, so at least on this particular test, they assume that you knew the surface area of the sphere formula. They'll assume that you know about circles, squares, rectangles, all those two-dimensional shapes. They'll assume you know quite a bit about those. sure it was nice of them to have only negative. Actually, one of them should have been positive 48 pi. Maybe another one negative 48 pi. But that would have been a good idea. All right, it's super close. All right, here we go. 3 questions left. Here's number 10.
Yeah, that's amazing.
Oh, yes. I think there's been one of these questions in every group this week. These are always challenging. Think it over, maybe draw a picture. About 10 seconds. Hopefully you've narrowed it down to where you can give an educated guess. All right, let's talk this one over real quick. That was number 10. 10. Okay. What was the common? What was the common wrong answer here? E, D. Okay, gotcha. Okay, gotcha. Okay, so did you guys draw a picture of this? I think you should. So it says you've got some function that is continuous, and f of negative 2 and f of 2 are both 0. So those 2 points are on the graph of f, and we are told that f is continuous, and I think it's really important to note on the closed interval. So it's not continuous on an open interval. If it was continuous on an open interval, then really it could do this or any other variety of things. It's continuous on the closed interval. That means our endpoints have to be connected to all the other points on the graph. So I think that might be a key for you when it comes to D. So then it says there is no C on the open interval for which f prime equals 0. Which of the following statements must be true? The idea of f prime being 0 is pretty important because if f is continuous and if it were differentiable, then it would maybe look something like that, right? And since the average slope is 0, the average slope being represented by my purple line right here, average slope is 0. That means by the MVT, you'd actually have to have an instantaneous slope of 0 somewhere in there. But what they're saying is that we don't have an instantaneous slope of 0. So there's really only one way to do this. If you have a continuous function and in this scenario, and f prime never equals 0, it has to have some kind of a sharp point. You know, maybe it's something that looks like an absolute value-ish. I mean, it could look different, I suppose, but it's got to have some element of a sharp point to it, or sharp points in order for it to fit this. So then if you selected D? So this, I mean, really, if you draw the picture, that really eliminates ABC. Then you look at D was the common wrong answer. It says that for the open interval, f prime of k exists, but f prime is not continuous. This is difficult because this part, I would say, is true. F prime won't be continuous. But to say that f prime exists is false, because right here at that sharp point, that would be a place where f prime doesn't exist. So for example, if I use that graph and I tried to graph the graph of f prime right on top of it, f prime would look something like that. It would be a double open on that sharp point, and so the double open just means that f prime doesn't exist there at all. So then E is the correct answer, basically saying on the open interval there's some place where f prime doesn't exist, saying essentially there is a sharp point in there somewhere, and at a sharp point you do, like I said, you do get the double open. It's not like one of them's open, the other one's closed. From the left or the right, the derivative just does not exist at that sharp point. Question, Johnny?
So I was just wondering, what if you just had a flat line from -2 to 2?
What if you had a flat... Well, so then that would mean that f prime did equal 0, and it tells us that f prime never equals 0. It says there is no C for which f prime equals 0. So, yeah, like the scenario you mentioned is very conceivable, but they're just telling us that that never exists. Yeah, good question. Any other follow-ups? Okay, awesome. Let's see where we stand. It's still ultra close. There at the top. All right, here we go. 2 questions left. Otherwise,
Do a non-calculator to end it.
yeah. Otherwise, I think we might run out of time. Get done like 40 minutes early.
Yeah.
I'd rather get some work in.
Why don't we do it in 4 days and also where's the timing at?
Yeah, definitely. All right. Going into the last question. Here we go. There's your leaderboard. Question 12. That looks like the right balance. That's as good as I can get it. Sorry, guys. City located beside a river has a rectangular boundary as shown in the figure above. population density of the city at any point along the strip, X miles from the river's edge, is f of x persons per square mile. Which of the following expression gives the population of the city? The river's on the left edge. The dimensions of the rectangular city are 4 by 7. It's a good units question for sure. Trying to guess, about 5 seconds left. Answer was B. You guys want to discuss? Okay. Like I said, this is a really good units question. Let's check it out. So with something like this, it gives you a population density. And really importantly, it says the population density at any point along a strip, X miles from the river's edge, is f of x persons per square mile. So when I think of a strip from the river, I'm thinking of like a little tiny rectangle, little representative rectangle, something like that. So all along that little tiny strip, really skinny strip, the population density is f of x. So when you think about a definite integral, whether the definite integral is from 0 to 7, 0 to 4, whatever it happens to be, isn't it a definite integral simply an infinite summation? It's an infinite summation. And so I need to add up the number of people because it wants to know the population of the city. So if I add up people per square mile, that's not population. If I add up people per mile, that's not population. I need to be adding up people. So I have a sense that I'm going to be integrating f of x, but I know the units on f of x are people per square mile. And so I need to multiply that f of x times square miles. Where I get that from is this little strip of property, x miles from the river. The area of that little strip would be a length of 7 times a width of dx. And 7 and dx are both in miles, so that would be square miles. Looking at the units here, the square miles would cancel out. Then as far as, I suppose this would probably give you a sense of what the answer ought to be, but as far as the limits of integration go, we're going to be accumulating these little skinny rectangles from the left side of the city over to the right side of the city. So I'm going to start 0 miles from the river, and I'll finish accumulating when I am 4 miles from the river. And so then when you compare this with your answers, maybe you can see that B is just like it, except the 7 has been moved out of the definite integral as a factor. So you derive at that. So I think units, like realizing that each of those pieces has units, is really important to decipher what goes where, and then just accumulate to get your limits. So any follow-up questions from anybody? Okay. Let's look at our leaderboard on this one. This was our final leaderboard for this Kahoot. And it was Maya, and Maya was it really Maya?
Yeah.
You misspelled your own name.
Well, kind of.
Well done. I like it. Caroline, was that really you? Caroline, who is print in wrong? Not espresso today. Okay. I like it. Keeping us on our toes. Who is Kahoot? Jordan, nice job. Mango Pulp. Nice work. Alexis. Okay. Hey, And guys, we're going to do a little bonus Kahoot. It's not going to be nearly as long as what we just did. This will give you a chance to finish, hopefully on a high note. So give me just 1 second here, and we will restart a different Kahoot in just a minute. We'll only do part of this. We'll stop this a little bit before 9. All right, so rejoin this Kahoot, or join this Kahoot, I guess. And this Kahoot is no calculator. No calculator. I think we have a different winner every time. All right, we'll get started here. Let's see how y'all do with no calculator for these last few Kahoot questions. All right, here we go. Remember, no calculator on these. Gotten a decent number of views on the videos that I posted.
Oh, you have?
I thought it might be 0, but it definitely has not been. I'm assuming that it's our students. I'm assuming it's not some
It's on
random.
YouTube.
I'm posting it on Schoology. Or I'm posting on Schoology and then sending out an update saying it's posted. All right, that's obviously pretty good. 2 Carolines, a Sam, a Maya in Canada. All right, here we go. Here's question number 2, no calculator. Remember, no calculator. So I would say at the end, we have 5 minutes left. See if we can arrange these brown tables back over here, kind of in that little semi.
Oh, you think so?
Oh, wait. Yeah, kind of like a, just get the kids to like kind of facing the desk, sort of like just a staggered everything, and then the round tables,
I'm just gonna,
the facilities people take care of the round tables, I guess.
yeah.
And the other rectangular tables.
I'm like, well, I don't know, maybe we should.
Well, I don't know where to put them.
I know where I got the round tables from.
Oh, from where?
From the room down by the bistro down there.
Oh, okay. I just say have the kids, they can walk down there real quick
Yeah.
if you want. And then maybe have just the folding rectangular tables. I think there's that rack out there.
Yeah.
All right, doing good. All right, here's question 3. This is definitely an improvement from day 1 on the calculator. I can't believe this is an AP question.
Yeah.
It's so easy. It's probably the type of question that would not appear now with the new framework.
Yeah.
I feel like new framework, they're like connecting topics more, like they might have some equation like that, but it would be within like a more complex
Mm-hmm.
application. So like the mechanics would still be pretty easy, but like the what do you do with it, you know, they'd maybe say that that's like a velocity,
Mm-hmm.
what's the acceleration,
Mm-hmm.
right? This is like such a basic skill question. Any questions on that one? All right. That's kind of a surprise. I thought that was going to be the first perfect one. All right, we just got a few more left here. Here's question 4. Graph of function f is shown above. Which of the following statements is false? Limit as x goes to 2 of f exists. Limit as x goes to 3 of f exists. Limit as x goes to 4 exists. Limit as x to 5 exists. Option E, the function f is continuous at 3. We're looking for the false statement. False statement. This very definitely could be a question that they would be asked now. All right, good job. All right, super close. 3 Mayas in the top 5. It's a good day. Question 5. Remember, no calculator on this one. Man, we can never get it perfect. All right, nice job. Okay, this is going to be our last one for this Kahoot. Question 6. We're going to move on to FRQs. We're going to do one more, and that'll be our last one. Question 6. Last one for the Kahoot. Here you go. It's a good one to finish on. I like this. Gotta do some. Remember, this is no calculator. You have to do a little computing. That's an old saying, you preach what you need to hear.
Yeah.
Yeah. Temptations for the comment. Wonder how many forget the 50. Assuming the answers will be B and E, right? But there is no B. Why didn't I should have included B. Oh my goodness. Let's take a look at this one real quick. All right. So symbolically, I think what you would do here is you would want to say the amount at 15 hours would be 50 plus the integral from 4 to 15 of R of t. Does that make sense? It'd be really easy to forget the 50. That's basically initial amount plus change gives you final amount. And we are supposed to use a right Riemann sum. So a right Riemann sum would be, or let's do this over here. It would be 3 times 6.2. I'm getting that from the 3 there and the 6.2 there. So instead of doing a right sum, and then it would be 5 times 5.9. And then the last one would be plus 3 times 5.6. So you got to do a little arithmetic there. So you have 18.6 plus 24.5. No, 29.5 plus 16.8. And let's see here. I suppose you might actually be able to just I don't know if you estimated this. 19, 48, 65. No, that's not going to go very well. So if you add these up, goodness, they're going to make us do this, aren't they? So what do we have? 47.5, 48.1 plus 16.8. I guess it's down to, well, yeah. So if you do this, you get 64.9. So if you answered with A, I guess you forgot the 50. So 50 plus 64.9 is 114.9. So yeah, what were the... Does that make sense? I'm kind of curious. So was it A's and C's? Yep, it was A's and C's. Okay, so for those of you that answered yellow, I guess you just forgot the 50. All right, final leaderboard is right here. Snack, who are you? Nice work. Nice job, Jasmine. Caroline, is that the real Caroline or a fake Caroline? Caroline? That was you? That was you? All right, awesome. Did we go back to Chav here? That's nice work. Well done. Emma, is it the real Emma? Nice job. And was it the real Maya? Yeah. It was the real Maya. Okay, hey, great job. I know it's super competitive. It's hard to get into the top 5, so if you're in there at any point, that's pretty impressive. Okay, we're going to hand out the FRQs.